Hello, metric class. In today's lesson, we're going to be looking at general solutions. And without any further ado, let's just get right down to the lesson. So for the first question, we have sine 2x cos 10 degrees minus cos 2x sine 10 degrees. And looking at our angles here, we can tell this is a compound angle, right? So every time you're solving this, you want to keep your formula sheet close to you so that you can see any similarities there and see if you can reduce any double angles or compound angles. So let's check here. We have sine A minus B, and then sine A cos B minus cos A sine B, and we can see, looking at the question that we have, we can see that we have something similar to this one. So but we are given the one that is on the right hand side, so we need to reduce that one to one trig ratio here, which is sine A minus B. So that means having to write this one, we have sine in bracket 2x minus 10 degrees, right? And then that will be equal to that cos 3x, right? Now having to work with this, we know that when solving our trig ratios, when solving our general solution, we cannot work with trig ratios that are different. So you can see this side we have sine and this side we have cos, and again we cannot make this a tan type because of the angles that we have here. The angles are not equal, they're not the same. So our only chance is changing this one to its cofunction sine. So moving to the next step, we'll have sine and then 2x minus 10 degrees, and then changing this one is equals to sine, and then to the cofunction it's 90 minus 3x. Now at this point we can see that our trig ratios are the same. We are working with sine both sides, so we can just cancel off the sine, and then we'll only be left with the angles inside the bracket. So that's 2x minus 10 degrees, and then is equals to 90 degrees minus 3x. At this point you now have to indicate that you have your reference angle, right? So at this point, this is your reference angle. And then what do you want to do? You want to check where is sine positive, because we can see our reference angle is positive. So we know sine is positive in the first quadrant and also in the second quadrant. So now we want to produce general solutions for the first quadrant and the second quadrant. Now for the first quadrant, it's quite easy because you just take the angles as they are. So you just take your reference angle as it is, then 2x 10 degrees is equals to 90 degrees minus 3x. Now at this point, what do you want to do? So you say plus k 360 degrees, right? Now you can bring over whatever all the x's to one side. So you have 3x plus 3x is equals to 90 degrees plus 10 degrees. And then that is equals to plus k 360. So some might write n 360, some k 360, it's all the same. Then here we have 5x is equals to 100 degrees plus k 360 degrees, right? Now at this point, what do we want to do? Just want to divide everything by 5, even the period here, divided by 5. Then we have x is equals to 100 divided by 5, that's 20 degrees, plus k 360 degrees divided by 5, that should give us, we have 72 degrees. And then now let's solve for the second quadrant. Having to solve for the second quadrant, we know the angle now should be 2x minus 10 degrees, and that's 180 minus the reference angle. But remember, our reference angle now is 90 minus 3x, right? Then plus k 360 degrees, right? Now at this point we have 2x minus, so 2x minus 10 degrees is equals to 180 minus 90, that's 90 degrees, and negative, that's plus 3x, and then plus k 360. Again, you want to have all your x's to one side, so that's 2x minus 3x is equals to 90 degrees plus 10 degrees, then plus k 360 degrees. Now what is 2x minus x? We have 2x minus 3x, that's minus x, and then 90 plus 10, that's 100, and then plus k 360 degrees. Now dividing everything here by -1, you will now have x is equals to -100 degrees plus k 360 degrees, right? Now you can say plus or minus here, and then that's indicates for k element of integers, also for this one for k element of integers. So now like that you have your two general solutions. Okay, now let's look at the second one. So here we are given cos squared x is equals to 3 sine 2x, right? Then from this square here, we can tell that this is a quadratic type general solution, right? Whereby we'll have two trig ratios that will give us different general solutions. So the first thing that we want to do here is write out this one. So this is cos squared x. And then looking at your formula sheet, we can see that this one is a double angle. So you want to look at your formula sheet, and then you can see that sine 2x here gives us 2 sine x cos x, right? So you want to break that one to that. So we have 3, and then in brackets, let's just break that down. So 2 sine x and then cos x, right? Then we have cos squared x is equals to 3 times 2, that's 6 sine x cos x, right? Now at this point, I know that it would be tempting to just divide both sides by cos x, but then that's not what you want to do. For a quadratic type question, you want to have two solutions. So dividing out will just give you one solution, which would be a problem. So now what you want to do is take all this and bring it over to the left hand side. So we have cos squared x minus 6 sine x, and then times cos x, and that's equal to 0. At this point, we can see that we have a common factor of cos x, so we can just factor out this cos x, and then here we'll be left with the cos x, because remember that's cos x, and equal to 0. Now at this point, you can just take this cos x and equate it to 0, and then have whatever that's inside the bracket equated to 0 also. Then cos x minus 6 sine x is equal to 0. Now having to find the solution to this one, you have x is equal to cos, shift cos, and then that's equals to x 90 degrees. So that's your reference angle for cos. Now let's continue with this one. So transposing this 6 sine x over to that other side, we can now see that if we divide both sides by cos x, we'll be creating a tan type. So because we have sine x over cos x, that will give us tan, and then cos x over cos x, that's 1, and then we have 6 tan x, right? Now continuing with this one, we have, so tan x would now be 1 over 6. Now let's calculate the reference angle for that. We have tan arctan 1 over 6, and then that's x is equal to 9.46 degrees, and that becomes our reference angle for tan. Now looking at cos, we'll say, where is cos positive? So we know cos is positive where? In the first quadrant, right? So for the first quadrant, that means we have x is equal to 90 degrees plus k 360 degrees, where k is an element of integers. Now again, we know that cos is positive in the fourth quadrant, right? So for fourth quadrant, we have x is equals to 360 minus the reference angle. So minus our reference angle, that is 90 degrees, and then plus k 360 degrees. Now we have 360 minus 90, that will give us 270 degrees. So that's 270 degrees plus k 360 degrees, where k is an element of integers. Now let's go ahead and find the general solutions for tan. So for tan, remember tan, our reference angle is 9.46 degrees. And now we'll be looking at where tan is positive. Tan is positive in the first quadrant because all three ratios are positive there. So we have x is equals to 9.46 degrees plus k 180 degrees. Why k 180 degrees? Because we know the period for tan is 180 degrees. Then indicate where k is an element of integers. But we also have tan being positive in the third quadrant. So that means we have x, and then that's equals to 180 plus our reference angle. So where do we get all this? We get all this from the cast diagram, where we know start here we have our 180 degrees minus theta, 180 degrees plus theta, and then 360 minus theta. So these are the angles that we use in general solutions. But for the first quadrant, you just take the angles as they are. So there's no 90 minus theta here. So you just put your angle as it is there, because the angle, we understand that it will be an acute angle. Then this is x plus k 180 degrees, and then 180 plus that should give us 189.46 degrees plus k 180 degrees, where k is an element of integers, and that will be your general solutions for that question. Now let's look at the third one. So we are given 2 sine x is equals to sine in bracket x plus 30 degrees, right? Then I know it would be tempting to just come here and say, okay, we are now working with sine and sine, so we can just drop this 2 and x and then drop all that. But then that doesn't work like that. It would be incorrect to say that, because you can see here, as much as we do have the same trig ratio, but then here we have a coefficient, right? So at this point, we want to check this one. Remember, in grade 12, we know that you can either be given a double angle or compound angle. So which is why you want to keep your formula sheet close to you. Now, having to look at this one, we can see that we were given sine x plus 30 degrees, which you can see here, this one will correspond to the first one here, whereby we have a plus b, and then you can see here x plus 30. So this one would have to expand to the one that we have here on the right hand side, and that will be no problem to us, because we can see that we are working with a special angle 30 degrees there. Now, okay, this is 2 sine x, and then let's expand this one. This becomes sine x cos 30 degrees plus cos x sine 30 degrees, right? Then having this one, we have 2 sine x. So we know our special angles. This is sine x, and then cos 30 degrees will become adjacent. So this is 30. This is adjacent over hypotenuse, root 3 over 2. Then plus cos x, and then sine 30 we have 1 over 2. Remember, sine 30 is opposite over hypotenuse. So that's a half, 1 over 2. Now we have 2 sine x is equal to root 3 over 2 sine x plus 1 over 2 cos x. Now at this point we can see that root 3 over 2 sine x and then 2 sine x are like terms. So let's transpose that one to that other side. Then 3 over 2 sine x is equals to half cos x. Right, now having to work this out, it becomes 4 root 3 over 2, and then sine x is equals to 1 over 2 cos x. Now at this point, what do you want to do? You want to multiply by the reciprocal, 2 over 1, and then also what you do on the left hand side, you also want to do on the right hand side. So you have that this 2 will cancel out with that 2, so you'll only be left with 4 root 3, and then sine x is equal to cos x. Now at this point we can see that we can make this a tan type by just dividing by cos x. So divide by cos x. Now what is it that we're gonna have here? We're gonna have 4 minus root 3, and then tan x is equal to 1. Now dividing both sides by 4 minus root 3 over 4 minus root 3, we have now tan x is equal to 1 over 4 minus root 3. Now at this point we want our reference angle, so leave the x here, and then tan inverse tan 4 minus root 3, right? Then if you just punch that in your calculator, you will have x is equals to 23.79 degrees. Now again, you are looking for where tan is positive. So tan is positive in the first quadrant. In the first quadrant, you just take it as it is, 29.79 degrees plus k 180 degrees. Remember, we are working with tan, and the period for tan is 180 degrees. Then let's look for our general solutions in quadrant number 3, where tan is also positive. Then we have x is equals to 180 degrees plus the reference angle, 23.79 degrees plus k 180 degrees. Now having to add that 180 plus 23.79, we get 203.79 degrees plus k 180 degrees.